Hello, Algebra 2ers. So, because Algebra 2 is the study of functions, I just want to take a second and review functions and function notation, because we'll be using it so much throughout the semester. So, a little bit about functions and function notation. As a reminder, a function is defined as a relation where every input, also known as x, right? Every input has exactly one output, or those y's. So when we were in Algebra 1, we kind of threw some things here on graphs. I'm going to quickly draw some axes for us. You can just jot these down. So we were looking at functions and we're like, hey, what is a function? What's not a function? So let's just remind ourselves of those. So we might have had something that looked like, I don't know, like this. That's a function. Absolutely, yeah, right? That's a function. Or we might have even had something crazy that was like these little squigglies, but still a function. It passed that vertical line test, and it worked for us. Still a function. For every input, there's exactly one output. Now, we might have had something that looked like this. We went into a little problem there. Not a function, because there are multiple outputs. So for instance, 0 here, right? An input of 0, you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 5 different outputs that you could choose there. So that one's not a function. All right, now when we have these functions, we have this certain notation, or the way that we write it. So let's review in terms of, function notation. Our function notation. So we might have something that looks like f of x, remember that little of in there, f of x is equal to 3x plus 4. All right. Now this little f is what we name our function. So the name, that didn't spell right, a name of function. And sometimes we name it with an F, a lot of times or G, H, any kind of letter that you want there, because you want to name your function. We're going to be talking about different functions together, so it's really important that you name them. Then this X, or whatever's inside your parentheses here, inside your parentheses is your input, or what you're plugging into your function. So you can plug in anything that's in the domain. So what you're plugging into your function. Now this entire f of x, so this entire thing is our output. All right, and remember we say this as f of x, it's the output. Now oftentimes we put this with y. So often called y. So f of x and y, they're very similar, they're very interchangeable. But when we have functions, we isolate that f of x. And then of course we actually have our real function. So this is our function, 3x plus 4 in this case. It's the function, or what we might call the rule back in Algebra 1, of what's going on. Right? So kind of the manipulation of that input to get your output. So if we're looking at these examples, I might ask something like, if we have f of x equals 3x plus 4, I would say, hey, what's f of 10? And we'd take that 10 and we'd input it wherever the x is. So we would say 3 times 10 plus 4. Then, of course, we would simplify this. 30 plus 4, that's 34, meaning that f of 10 is equal to 34. You can also think of this as the point on the graph, 10, 34, with your x as 10 and your y as 34. So far, pretty simple. Now let's introduce a little bit of a different function here. Use this kind of peachy color. Let's introduce g. And g of x, it's a different function, I named it with a different letter, is equal to negative 2x squared minus 3x. And I'm going to ask you, I'm going to say, well, what's g of negative 4? AKA, what's the output when the input is negative 4? And the reason I want to point this out here is that we have to remember our order of operations and our negatives here. So as you can see, wherever that x was, I replaced it not only with parentheses, but with the negative 4. And order of operations tells you have to do your exponents first. So I'm going to go ahead, I'm going to solve this negative 4 squared. I'm also at the same time going to simplify that negative 3 times negative 4. So this is now a negative 2 times a positive 16 plus 12. So a negative 32 plus 12 gets us a negative 20, meaning that g of negative 4 is equal to negative 20. And again, we can think about that point as negative 4, negative 20. And we also have the option, of course, for if we're given an output, we can solve for x on the input. We just replace it and solve. Now the last part I want to point out is a graph. I'm going to put it over here on the right-hand side, start with some axes, and I'm just going to go ahead, I'm going to make up a function here. We'll do it in this purple. Let's do, here, this sounds like a good one. Oops, there we go. And then we'll go over a little bit. And then we'll kind of do a little loop and come back up. So this is a function. It's a function right here. For every input, there is exactly one output. It might not have exact equation with it, but it definitely is a function. And we're going to call it, we'll call it h of x. So this function is called h. And we can still figure out our inputs and our outputs even though it's from a graph. So my first question would be, what's h of negative 2? And so you have to find negative 2 here on the graph. So negative 2 is here. And when you line that up, you get this point. You're saying right here, the point on this graph is negative 2 with the output of a positive 1. So h of negative 2 is equal to 1. And we can find that out from looking at the graph. We could do that again with what is h of, let's say, 1. And we can go h of 1. That lines up with this point right here, which is 1, 2. h of 1 is equal to 2. This also works for the output. So I would ask h of x, what is x when h of x is equal to negative 1. So when the output is negative 1, we can see right here, here's an output of negative 1. The point is 1, 2, 3, 4, negative 4, negative 1. So x is equal to negative 4 when the output is negative 1. And that's just a little bit review on functions. We are about to introduce to yourself some parent functions. So some functions that you are going to have to know for the rest of the Algebra 2 school year, which I think that you will get very familiar with. See you tomorrow, everyone.